Today we're doing the Kinetic Energy Lab. The easiest way to do the Kinetic Energy Lab is for me to actually demonstrate the lab for you on the table, and we'll collect some of the data on the board. You will then take the data from this video, put it into your own sheet, and then you will finish the lab using my data. That's probably the easiest way to do it right now. So we are talking about kinetic energy. Kinetic energy is energy in motion. So when we have energy in motion, we have to have velocity as part of our calculations. And you can see that the formula is 1/2 mass times velocity squared, which means we take velocity times velocity. You have to take it twice. And then we have the mass. Well, if you think about it, the bigger, heavier object, remember, drop in the book, the bigger, heavier object that you have means more energy. So in all of them, mass becomes very important because the weight or the force of the weight has an impact on the amount of energy that it carries. So we're looking at this. Now, if you're going to type this in on your calculator, this formula, then the formula is really written as KE, and it's kinetic, and the little e stands for energy. And that's equal to 1/2 times the mass times the velocity squared. That's generally the formula we use when we're doing this. But if you're going to type it in on the calculator, here's how I do it. I hit the velocity, I put in the velocity, I square that number, times 0.5, times whatever the mass is. So that's what we're talking about. Now remember, to get velocity, we're going back to distance divided by time. We don't ever get away from using these formulas over and over again. So we're working on this lab about kinetic energy, and my question for today is, does the velocity affect the kinetic energy of an object? And more importantly, how does the velocity affect the kinetic energy? If you double the velocity, do you double the kinetic energy? Or if you double the velocity, it only goes up a little bit. And so we're going to work through this lab, and what we've got is we're going to build a ramp, and we're going to calculate on this ramp. We're going to find the mass of the object, we're going to find the velocity of the object, and then you're going to calculate the kinetic energy of the object. So if we're talking about rolling a marble down a ramp, and that's what we're going to be doing, we're going to roll a marble down the ramp. We're going to do 3 trials. So the first thing we need to do is experiment 1 is the ramp is at 3 centimeters. So what I've done is I've measured these, and they come out to be 3 centimeters. So I can actually put my ramp on top of one of these, and we can roll the marble down. Now the other fun part about this is that I cut all these at exactly 1 meter. So if I start at the top, we can just time it rolling down to the bottom of the ramp. Well, the first thing we need for our trials, though, is the mass. So we're going to roll a marble. To get the mass, we use a digital scale, and we place the marble on the digital scale, and it reads 5.4. And so because this is in kilograms, you have to divide your number by 1,000. So 5.4 divided by 1,000 is 0.0054 kilograms. Now here's the fun part. If we use the same marble over and over again, we don't have to reweigh it. So every one of these numbers is exactly the same. All right, so now, what's the distance that we're going to travel? Well, the distance is 1 meter. That makes math easy because the distance is 1 meter. And if we use that the same every single time, we don't have to remeasure that either. So we're going to put in 1 meter, 1 meter, and 1 meter. Now here's the fun part. We have to time the marble rolling down and figure out what that is. So I'm going to use an app on my phone called the Huge Calculator. And you can see right here, if I start and stop, it gives me a time on this. So what I am going to do is I'm going to take our marble. I am going to set this down right here so I can start and stop. And so when I let go, I hit start, and we get to the bottom, stop. And so for my first time, that's what goes here, I got 3.5 seconds, all right? You need to write that in. My next time, here we go, let's do trial number 2. I got 3.51 seconds. What does that tell me? It tells me I'm doing it right, because if the times are the same, I'm doing something right. All right, one last time. Okay, and 3.6 seconds. All right, so to find the velocity now, because remember, we're looking at the kinetic energy is equal to 1/2 times the mass times the velocity squared. So we now have to find velocity. And to find that velocity, you have to take distance and divide it by time. So what we're doing here is 1 divided by 3.5. And that technically should go into this one, 1 divided by 3.5. And that equals, let me bring up my calculator. 1 divided by 3.5. That equals 0.29 meters per second. All right, so that equals 0.29 meters per second when we do the math on. Now, the next step, of course, is to calculate the joules. And to do the joules, it's 1/2 times the mass times the velocity squared. But if I told you how to put it in on your calculator, I want you to put this in, 0.29 squared. So you're going to put in 0.29 and hit the squared button. And then you're going to multiply that by 0.5. And then you're going to multiply that by the mass, which is 0.0054. So 0.0054. And that'll give you a number right here. So if I put that in on mine, I get a number of 0.00022 joules. All right, that's how we're going to do it. Now, I hope you guys can understand how to get the velocity and how to get the joules. I am going to do this part for you. Your job now is to finish these last two. And the real question is, again, what happens when you double the speed? And I'll let you guys fill this one out. Hopefully you have the data right there. So the question is, what happens when you double the speed? Well, we know from our earlier labs that if you double the height of the ramp, you double the height, you double the velocity. So in the second experiment, we're going to do the same thing, only this time we're going to do a 6 centimeter ramp. Now, mass of the marble is still the same. It's still 0.0054. The distance traveled is still the same. That is 1 meter. Now we've got to run the time. So here's how it looks. So if I'm going to double the height, I grab another one of these and set it on top, set it on top. We're ready to go. Now I'm at 6 centimeters. All right, so let's get our times. Let me reset. All right, here we go. And I got 2.3. Let's do the next trial. $2.2. And the last trial. Oops, I didn't start my stopwatch. See, it happens even with the best of us. Here we go. And the 2.2. All right, so when we're set up on this, now, because you did the same thing, remember, this is distance divided by time. Here's your distance. Here's your time. You take this number divided by this number, gives you this number, all right? This one is 1/2 mass times velocity squared. This is 1/2 mass times velocity squared, all right? So what you're going to do is you're going to take this one, velocity, you're going to square it, all right? Velocity squared times the mass times 0.5. And you should be able to fill these out. Now, when you're done with this, you're getting the numbers from me here. Make sure you fill these out, do the math, get it done. There are a couple questions at the bottom that you will need to ask or need to answer. Make sure you get those done and answer the questions, because those are the big ones that I'm looking at to see if you really understand what's going on. As always, if you have questions, make sure you find me, and we'll try and help you the best we can. You guys have a great afternoon. We'll talk at you later.